All right. Hello, everyone, and thank you for attending today's GatesAir Connect webinar. This one is brought to you by Ted Lantz, our Senior Manager of the Radio Products line, and it will be on HD radio time and level alignment. Very important topic if you are a digital radio broadcast engineer here in the States and wherever HD radio is, and it was definitely a topic people were interested in learning about. We're going to get to that webinar here shortly. We'd like to give some time for more viewers to log in and get settled in. So we're going to have a 3-minute intermission, and then we will start the webinar shortly. So again, thank you very much for attending. Hang on out, and we will start that countdown right now. Thanks. All right, welcome everyone to yet another GatesAir Connect webinar series event. My name is Keith Adams. I'm the Marketing Communications Manager here at GatesAir, and I would like to present you Ted Lantz, who will be delivering the presentation today about HD radio, dynamic time alignment, and audio correction. He's going to talk a bit about HD radio diversity, delay drift, and the ways that you can optimize your alignment and synchronization of your digital and analog signals and make sure that your time and levels are aligned properly. At the end of his presentation, we will definitely have a Q&A session. If you use our website or YouTube Live, you will see that there is a chat area with which you can type in your questions. We'll answer them on a first come, first served basis. We actually have a couple from email as well. And so please type those questions in at your convenience, and we will answer them at the end of this presentation. Without further ado, I will head you over to Ted Lantz, who again is going to talk about HD radio, time, and level alignment. Ted?
Thank you, Keith. So as Keith said, we'll spend a little bit of time going over a few different things about the time alignment and the audio correction for HD and your analog signal. We'll discuss some things, why it's important, different reasons for having your drift, as well as that can happen with the time alignment, as well as some solutions, some available solutions out there to be able to correct for it. So why is the time alignment important? Basically, what happens in the with the HD signal is there's and the way the receivers work with the system itself is it first picks up on the analog signal. Then as you have a strong digital signal, blends over to the digital. And during that transition, as long as everything's time aligned and the audio is correct, you have a perfect seamless transition. You always have a diversity delay between your FM analog signal and the digital itself. That's approximately 8 seconds. And why it's important to have the time and the level alignment between the two signals is so that it enhances the user's or the listener's experience, so they don't notice transitions, so that it's just a smooth blend between the two, and they really don't notice it going between the analog and the digital. So a little bit of an overview on HD for those that may not be as familiar with it is the whether it be an FM system or an AM system, they're both hybrid type systems. So you have your analog signal, which you can see in the middle, FM that takes its normal bandwidth and channels, and then you have your digital signals that are on the side bands of it, in the upper and lower sideband of the off at if it's in MP1 mode, it starts at about 129 kilohertz, or if you use extended hybrid, it's around 102 kilohertz is where those digital partitions begin and move out to 198 kilohertz. So it allows you to have both your analog and digital signal at the same time, and the receiver picks up the analog and then transitions or blends to the HD. The diversity delay provides alignment between those two signals. Again, as I said earlier, it's inherent that the HD has a buffering or a within the system itself. And so what we do is we blend those two so that they end up having good transitions when you go between your analog and digital signal. And one of the things that we do where that generally, or where that can be done at, the diversity can be set up in a number of places. It can be set up in your audio processor. We'll discuss some other methods of being able to do that external to it, as well as in the exporter itself is another place that the diversity delay is set up so that you have alignment between the two. And then we'll go through some different ways that those are set up. So the specification for the time and level alignment of your HD signals, the NRSC committee has provided some guidelines and recommendations, and that's in the document G203, and that provides a lot of information about and gives you a guideline of how to set these up, as well as the information, some of the information that we're going to go through today. But basically the definition, so that you get proper and good blending between the two, is to be able to maintain the audio samples within plus or minus 3. So plus or minus 68 microseconds is what that comes out to be. And as long as you are within that type of audio samples, then you'll get good blends. If they go outside of that, and then as far as audio level, it's 1 dB. If it goes outside of that, then it's noticeable to the listener, and then we'll start to look at what some of those look like. So here are two different views on the as far as the blending, if you look at, and when you look at this, if you're off by 6 audio samples on the left, you can see that as you get halfway into the ramp, you have 3 deep nulls that are in the signal itself. The first one is around 4 kilohertz, like 3.6 kilohertz, and you have another one in the audio at 11, and that last one is a little over 18 kilohertz. So you end up with something that is noticeable to the listener. And as you look at 50 samples, you start to get a lot of different nulls in the ramp up time, or in the ramp of the system. During that, if you have a misalignment of greater than 5 milliseconds, it's very noticeable to the listener as an echo or a skipping. You will hear what's already been said previously, or it will jump back depending on where the misalignment is. So what are some of the reasons for the issue? Network congestion is one, and we'll discuss some of that and how you have and what that does and how the packets get delayed or lost. How you have the system set up as far as site configurations, which probably many of you have been around, whether it be the exporter located at the transmitter, the exporter located at the studio. Your GPS, the timing and synchronization that's associated with that. And then another thing that affects it is the audio processors and their configurations, whether they be separate processor for the analog and digital, which we did a lot of that in the beginning of the implementations of HD. Now there's a lot of different, single box solutions. And also within those processes of whether you have dissimilar presets. So all these provide reasons for the issue of having latency or the time alignment get misadjusted through the system. So first we'll talk a little bit about the network itself. So the E2X stream itself is it's a UDP stream. It's very bursty in nature. So it can offer some complications to the network in the implementation of the networks inherent in itself. But the E2X stream does take into account some of the timing characteristics that are associated with the networks or the interfaces themselves. But you're never guaranteed precise packet delivery. All networks have some loss, as well as the networks have some jitter. So those are all things that we have to accommodate when we're working with the system itself. Also, traditionally, the networks and many of the different network LAN extensions that have been set up provide for around 200 to 300 kilobits per second, where the E2X traffic at times, when it's so bursty in nature, needs 1.5 megabits. So this provides some of the issues that we have in the network, and having some fragmentation in packets or congestion along network, and all this ends up providing some of the time slip that we talk about. A single packet loss in the network itself can provide up to a slip of 92 milliseconds. So certainly far in extreme of where we want to be able to have perfect alignment between the analog and the digital signal. Then from the network, we move to some of the timing issues, and really with the timing itself, everything should be locked to GPS. The HD signals themselves are in the frames as they're transferred, they're asynchronous by nature. The exporter and exciter should be locked to GPS, whether they're 10 megahertz or 1 pulse per second, whether they're located at the studio or at the transmitter. And we'll look at some examples of that. And then without synchronization, and without, what you'll see, and what you get is you get the buffers going, increasing and decreasing, depleting or adding to the buffers that are built within the exciters themselves to be able to accommodate this E2X traffic. You see at the up there on the right, you have the exporter that can be, it's locked to GPS. They usually have 10 meg or 1 pulse per second out, or either or both, depending on the system. And then those are usually locked or can be used as references to lock your exciter. And then the importer itself is locked to 44.1 kilohertz word clock. So here shows a how much audio samples can vary in the real world based upon different situations. So in this particular example, the GPS is referenced on the exporter at the studio. So the exporter is at the studio. It has GPS reference. The exciter does not. And so you're sending the EDX traffic across the network. And this is showing how much delay, how much change in your diversity delay is through network congestion, as well as not having GPS lock at the exciter itself. And if you look at it, as you kind of look at it, this is a 4-hour view of the station in context here. And I think the network on this particular example is somewhere around 512 kilobits per second. So it has a awful big network as far as being able to send the packets compared to many systems that are out there, or some systems that are out there. And you can see variations of up to 210 samples that are moving around or jumping. So, it goes from minus 1,650 to 1,800 samples that are that are wandering or moving. So that ends up to a big difference, and again, noticeable to the user itself. In this particular example, then, once the exciter was locked to GPS, then that moved that from having this 210 samples difference to being zero, to being on to not having any samples, any variation in the samples initially when you first put it on. But over time, you'll still get some variations to that, again, part of it from a network, and just things not staying in continuous synchronization. And it went from being to zero to like 10 or 14 audio samples. So you still, through the network, lost some of the timing, but you did get it a lot closer than where it was without proper GPS timing. And there's a lot of different scenarios for it, but that's an example of one, and probably an example that occurs in a lot of different systems. Here's also, it shows the differences in the actual GPSs themselves. So when you look at the GPS on the left, it's an ESC, and it's particular, just in its running, you lose over 9.5 samples per second, compared to a more accurate unit being the NanoSync, which is the early ones that were implemented into the systems themselves. They have a lot better accuracy, and it shows that you are 113 samples over 7 days. So there are quite a bit of differences in the oscillators or the references themselves. And then the last one is the audio processing itself. Again, initially the easiest implementation, or what looked to be the best implementation, was to have separate processors. The analog gets processed differently than the HD. The FM has different things that it needs to accommodate. It needs pre-emphasis, where the digital signal itself does not. And you're doing a lot of competitive things in the market for your program density and your loudness that you want to present to overcome other issues. And so they're usually processed separately. And while that great thing to do. It also has introduced, also in looking at this and analyzing the HD systems more accurately, it's found to provide some of these delays and these issues that are caused in the blending between your analog and digital. There are some processing delay artifacts through the dynamics, as well as the make a model make a difference. You really, and we'll go through some of that, but you should have either be using a single processor that processes each of them separately, but it's in a common platform. Or if you are using separate ones, they should be by the same manufacturer or vendor, and using similar presets. Different presets can also affect the artifacts that you notice. So this shows the timing of that is affected from the audio processing itself. The exporter and the exciter are co-located at the transmitter site. It has an isolated E2X network, so there's nothing else on it that can cause delays in the network. It has properly locked, and this is a separate processor with dissimilar presets. And so what you can see in this one is over a 7-hour time frame that you have 150 samples that are lost just by having dissimilar presets themselves. They are the same boxes, just separate processing and different presets. Then what this shows is just how much variation that you can get in the actual timing between the analog and digital itself. So this is a station that over 18 hours has jumped over 2,500 samples, starting out at 6,000 samples, being off from 0, which isn't going to be good in itself, and then jumping up to over 8,000 samples missed. Then basically on the next few slides, I just show some examples of different things that that you see in markets, and it really does basically just say there's a lot of different things. It shows all the different things that we discussed affect it, whether it be the network congestion that's causing the drifting. You see at the beginning here some dissimilar processors in use, and so they cause an issue. And then you can have some synchronization issues that are a part of it too. So it just shows different scenarios of across the market of different implementations and different things that are happening. Same way with this, it shows the analog. There's, in this particular case, no processing problems, but that you do have drifting and jumping as associated to congestion or timing issues. Shows all examples. In this particular one, it shows at the beginning here almost 20,000 samples that the station is off. So it's almost a half a second off, and it's analog to digital synchronization. So with all those, what are some of the solutions? What are some of the things that can be done to eliminate some of these issues? One is cleaning up the network and making sure you have a VLAN and everything isolated from the network, from the business. While you need to get some of the information, they should be segmented so that only the E2X traffic and the associated pad data is moving on that network. You do need to synchronize everything like we showed earlier, and then you need to use the same manufactured processing as well as similar presets. And then with all that, you still don't get a perfect system. One of the systems that does work very well is to end up having the importer and the exporter be a direct connect, everything at the transmitter site. So you remove some of these elements of error and a direct connect, which is what this is showing here. The pros of that is the timing is stable. You avoid the congestion, and it's simple and effective. The disadvantage is it's not very easy to get all when you're using the secondary channels. It's not easy to get those secondary channels accommodated through the legacy STLs. There's just not enough bandwidth, and so that's a lot of times why they are separated. And the importer can be located at the studio and with the exporter at the transmitter site. And that is a TCP IP connection. So traditionally, and that's another thing that you'd have to have with that implementation, is to have a network that has bidirectional link so that you have the importer and exporter talking to one another. So you can see here, when you have everything co-located and everything, perfectly set up, then you really end up with no drifts and can have perfect alignment between your system itself. But those are not always the practical ways. So we'll look at some automated ways or some other ways of being able to solutions within the system to exist. Previously, everything always had to be set up manually, which again doesn't take into effect the different type of situations that we spoke about. And now there are some different ways of implementing systems that can help do these things automatically and keep and watch the systems in real time and make corrections for them. So one of the things that we've implemented in our new exporter is to be able to have off-air dynamic time and audio correction. So basically it does have an integrated receiver in it. It's in it goes in this split mode where you can have your HD signal and your digital. It goes to a peak cross correlator that monitors both those channels and then provides the signal correction and the audio sample corrections back to the delay control, whether it be digital or analog, so that you stay in time alignment within the plus or minus 3 audio samples. We'll keep it within plus or minus 1, and keeps everything synchronized for you so that you have a perfect blend between your analog and digital signals. And this just shows it, the back of it, where you'd have just a single input for the antenna to go into it, and then the receiver is built in. And it also provides all your other timing syncs as far as your GPS input and your 10 meg and 1 pulse per second in or out, depending on if you're using this to go sync other devices, whether it be your exciter or exporter. Or it can be integrated so that your exporter is also an embedded process now, and then everything would be within this box itself. Other methods of providing the auto correction is in the receivers themselves, working with the traditional boxes, which would be in GatesAir's case, the HD 200, and in Altel, their Exporter Plus. So they Sequera, the Bell-R, they're able to pick up the off-air signal and provide through Ethernet the information back to the units to be able to provide the proper number or the proper samples so that we can adjust the exporter or the receiver or the processors also if you're using the processor itself, and then those will do the auto correction for you. And it's just so it's a Ethernet connection back to the devices, keeping everything in time alignment and providing us with the information to be able to move things, the delay itself. So that's the pros to that is it's simple, they're effective, they work with your legacy equipment, and it keeps, again, everything in alignment as we were talking about. The disadvantage is it does require additional hardware and it's not transparent, and you do have a little bit of receiver time slippage also. And then this just shows the same thing, only it's correcting only the correction that for the receiver from the Bell-R or the GatesAir would be going back to the processor rather than to the exporter. And then the second method to that is would be standalone boxes. As I mentioned earlier, is that we've implemented that into the embedded importer-exporter. Then also you have the Innovonics Justin that can do the automatic time correction as well as level correction as well as the GatesAir. So these pick up an off-air signal, and then they provide the alignment of the audio signal itself. They can be placed in the HD path or in the analog path, and they measure the diversity delay in a single device. This shows some of the implementations of that device going in. So if you had a single processor with the dual output, you would delay your analog signal, and you would provide a couple more seconds of delay in that so that you could put the digital device or the receiver with the delay built into it into the digital chain, and you provide a couple seconds of delay within it, and then you compensate that in the other device to be 10 seconds for the analog, and now it can adjust the digital delay back and forth to keep everything in perfect time alignment. And then this is just showing a configuration with dual processors. Again, in the digital chain is where the correlation receiver is being put in before the exporter. And then showing the other unit where you have an FM audio processor, an HD audio processor, and you put the auto correction in the analog chain. So it can be done in either one. And those are there to be able to, and then they give you some advantage in each of them depending on what you want to do. But they do keep you in time alignment. And so those are some of the different methods of, or those are some of the complications as well as some of the methods for being able to implement and be able to provide the time correction between your analog and your digital signals. I think now if there's anything, it would be open to questions. So if there's questions, I think you can put them in the window, in the chat or in the window to ask questions, and we can see if we can answer those for you. Thank you.
Awesome. Thank you very much, Ted. Yeah, there's, as usual, great information. And for those of you who will be attending the NAB show 2018, which is around the corner as we record this, I believe you're going to be one of the speakers at our GatesAir Connect event on Sunday. Is that correct?
That's correct. Yes.
Awesome. Yeah, Sunday, August or April 8th, I believe at 3 p.m. Is the time that we'll be having that at the Las Vegas Country Club. So, so in general, there'll be a lot of great information there, not just radio, but TV stuff. And you could actually talk to Ted in person if you have some questions. But speaking of questions, again, for people who have had a chance to put things in the live chat or send emails, we're going to ask Ted some of these questions right now. The first one was from email. A guy named Mike Perez asked the question, what is the reasoning for putting the autocorrection device receiver in the HD chain?
One of the reasons for putting it in or a couple of them, one is that it can also then be able to correct for your audio as well as your time diversity or your delay or slip in time, but it also can correct for the audio, as well as it gives you a little more by putting in digital. It gives you a little more, I guess I'll call it reliability or redundancy, less effect on your analog. So if something were to happen or you need to take that out of the chain, it doesn't affect your analog signal by having it in the digital. And so
Mhm.
it's it kind of removes a single point of failure also by putting it in the digital chain, since really still now, the analog is still probably, is still one of the more important, is the more important signal at this point.
Okay. So Roswell Clark asks, does the GatesAir solution, which I believe he's asking about the new FMXI 4G, does it do time, level, and phase correction?
Yes, it does monitor all three, and then provides you correction for all three of the different scenarios. Yes.
Um, and can you talk a little bit about how we're going to kind of showcase that a little bit at NAB show this year?
The product itself.
Yeah.
So we'll have the product at the booth, and we will be sending the. We'll have a signal going to it, and we will be showing uh, the HD signal itself in the exciter. So we'll have a live demo of the unit itself, I guess I should say.
Hmm.
Um, and it will be showing you some of the features that we've mentioned, as well as you'll get a look at an embed approach to both the importer and the exporter, where before, the exporter's always been, or the importer, I'm sorry, the importer's always been on a PC, and we've removed that from being a PC now. So there's no boot up time or, operating systems that you have to work with on the system now.
It's all in one.
Hmm.
That's cool. That's very cool. What are the pieces you're going to integrate it to? If there's a live demo.
We'll have it integrated with the IP link. So the IP link will be the GatesAir IP link will be sending the eDEX traffic to the exporter itself, and with that we will be showing we will be showing the robust, reliable link, as well as it being able to provide some signal shaping of the HD channel itself. So it gives us a more reliable link between the two, and allows us some advantages that way, as well as then, um, showing the traditional HD 1, 2, and 3. I think we may have 4 channels that we're actually showing on the system itself.
Hmm. That's very cool. Yeah, and for those listening who do plan on attending, we'll be in North Hall as usual, and our booth number is N3703. So definitely stop by the GatesAir.com site if you want to learn more. But while you're there, definitely stop by our booth, N3703. Um, at this point, we don't have any questions other than those two that came up. Um, but we can probably hang out for just a little bit and see if there are others. Is there anything that you're looking forward to showing people, Ted? Whether it's FMXI 4G or any other kind of cool things, liquid cooled FM. What neat things do you want people to know about with our radio products this year?
Well, I mean, I think a couple of the things that we've covered. I mean, I do think that showing the um, IP Connect with the exporter, as far as connectivity,
Mm-hmm.
and then the different things that we just spoke about here, and providing the broadcaster with some advantages and helping them and then be a more with the HD signal. And then from a transmission standpoint, we'll be showing the liquid cooled FM, as well as our air cooled FM products. And then and then we'll also have our solutions for the lower power that are the fax 3.5 down to the 50 watt, as well as the LX, and then the options and features that are associated with each of those.
Fantastic. Nice. Is I think the theme there is letting people know once the signal is on its way from the studio, it's in good hands. Uh, so that's great. That is great. I would say at this point, if anyone has any other questions that they'd want to ask, how would people get in touch with you, Ted?
They can send me an email. The email address is tlantz, TLANTZ at GatesAir.com,
Okay.
or they can phone, and my phone number is 217 257 7391.
Okay. And certainly, if people have other detailed questions, they can contact support, I would think.
Mm-hmm.
And our support is 24/7. Off the top of my head, I don't have that number. But definitely gatesair.com /services is a great way to get any information and contact that you would need us to help you out with. We also are, and as usual, anytime our customers and anyone interested has questions of or topics that they'd like us to do in any future webinars, that's something we are all ears and ready to hear about. You can contact me at kadams@gatesair.com or marketing@gatesair.com is another way to send some good themes and topics our way, and we'll see what we can do in future webinars. So again, we'd like to thank you guys for coming out. We want to thank you as well, Ted, for putting all this together. Awesome presentation, and definitely looking forward to Vegas as well.
Yeah, and if you have any questions, as Keith said, just let us know, or we'll see you in Vegas, and we can go through things there, where sometimes it's easier in person to discuss the different things that may be outside of even what we talked about today. There's many different things that are people's questions, and we'll be happy to answer them.
Awesome. Yeah, being able to see the product in person and see things operational, and also learn what people's scenarios are, their personal scenarios, is something that makes us pretty excited to see what kinds of solutions we can customize for you. So, and Ted is the man when it comes to that. So awesome. On behalf of GatesAir, we'd like to thank everybody again. And again, we look forward to seeing you in Las Vegas, and also with the next webinar, which will probably be in late April. We'll send out some information to everybody then. So again, have a great day, everyone, and thank you for attending.
Thank
Thanks.
you.